Welcome to Curiosity, the podcast where science meets wonder. Join us as we explore the fascinating, the innovative, and the unexpected, from the secrets of the cosmos to the marvels of everyday life. Each episode takes you on a journey to uncover the knowledge and stories that fuel our endless quest for understanding. Let your curiosity guide you.
Tracing the Digital Revolution, the History of Computers. The history of computers is a tale of ingenuity, problem-solving, and relentless innovation. It begins long before the electronic marvels of today, rooted in humanity's quest to simplify complex calculations and store information. The earliest concept of computing can be traced back thousands of years to mechanical devices such as the abacus. Invented in ancient Mesopotamia, the abacus was a simple yet powerful tool for performing basic arithmetic, demonstrating the human desire to create machines that could assist with mathematical operations. Fast forward to the 17th century, when pioneers like Blaise Pascal and Gottfried Wilhelm Leibniz revolutionized calculation methods. Pascal developed a mechanical calculator, the Pascaline, capable of performing addition and subtraction. Leibniz expanded on this by inventing a machine that could multiply and divide, laying the foundation for binary arithmetic, the basis of modern computing. These mechanical devices, though primitive by today's standards, were marvels of their time, representing the first steps toward automated computation. The Industrial Revolution of the 18th and 19th centuries introduced a wave of innovation, including the concept of programmable machines. Charles Babbage, often referred to as the father of the computer, conceptualized the analytical engine in the mid-1800s. This groundbreaking machine featured elements that resemble modern computers, such as a memory unit and a processing unit. Although Babbage's designs were never fully realized during his lifetime, his visionary ideas inspired future generations of inventors. Around the same time, Ada Lovelace, a mathematician and collaborator of Babbage, wrote what is considered the first computer algorithm. Lovelace recognized the potential of the analytical engine to perform more than mere calculations. She imagined a future where machines could process patterns and create art or music. Her foresight earned her recognition as the first computer programmer, and she remains a celebrated figure in the history of computing. As the 20th century approached, the desire for faster and more efficient computation drove the development of electromechanical devices. Machines like the Hollerith tabulating system, designed for the 1890 U.S. census, showcased the power of automation. Using punch cards to store data, these systems could process information much faster than manual methods, marking a significant leap in data handling. The success of Hollerith's invention eventually led to the founding of IBM, a company that would become synonymous with computing in the decades to come. The transition from mechanical to electronic computing began during World War II, driven by the need for rapid calculations in fields like cryptography, ballistics, and logistics. In this period, machines such as the Colossus and the ENIAC were developed, capable of processing thousands of calculations per second. These early electronic computers were massive, occupying entire rooms, but they demonstrated the incredible potential of electronics in computation. The mid-20th century marked a transformative era for computing as electronic machines transitioned from experimental projects to practical tools. One of the most significant breakthroughs was the invention of the transistor in 1947 by John Bardeen, Walter Brattain, and William Shockley. Transistors replaced the bulky and fragile vacuum tubes used in earlier computers, allowing machines to become smaller, faster, and more reliable. This innovation ushered in the second generation of computers and laid the groundwork for the rapid advancements that followed. During the 1950s and 1960s, computing technology became increasingly accessible to industries, governments, and academic institutions. IBM, with its pioneering mainframe computers like the IBM 704, became a dominant force in the industry. These mainframes, though large and expensive, could process vast amounts of data, revolutionizing fields such as business, engineering, and scientific research. Programming languages like Fortran and COBOL emerged during this time, making it easier for people to instruct computers and expanding their usability across various disciplines. Another major development of this period was the introduction of time-sharing systems. Instead of dedicating an entire computer to a single user, time-sharing allowed multiple users to access a single machine simultaneously through terminals. This innovation significantly increased efficiency and made computing more collaborative, fostering the growth of computer networks and the early precursors to the Internet. The 1970s saw the advent of the microprocessor, a breakthrough that would democratize computing. Invented by Intel engineers Federico Faggin, Ted Hoff, and Stan Mazur, the microprocessor condensed the core functions of a computer's central processing unit, CPU, onto a single chip. This miniaturization paved the way for the development of personal computers, PCs, which would revolutionize everyday life. Companies like Apple, founded by Steve Jobs and Steve Wozniak, and Microsoft, founded by Bill Gates and Paul Allen, emerged during this time, driving the PC revolution with products like the Apple II and software like MS-DOS. Parallel to these technological advances, computer graphics and user interfaces began to evolve. The graphical user interface, GUI, developed at research institutions like Xerox PARC, transformed how people interacted with computers. GUIs replaced command line inputs with visual elements like windows, icons, and menus, making computers more intuitive and accessible to the general public. By the 1980s, companies like Apple and Microsoft integrated GUIs into their products, leading to the widespread adoption of personal computing. Networking technologies also advanced rapidly during this era, culminating in the creation of the ARPANET, a precursor to the modern Internet. Initially developed by the U.S. Department of Defense for Secure Communication, ARPANET demonstrated the potential of linking computers across vast distances. By the late 1980s, these principles had been extended to form the World Wide Web, invented by Tim Berners-Lee. The web transformed the Internet from a tool for researchers into a global platform for information sharing and commerce. As the 20th century drew to a close, computing power and accessibility continued to grow exponentially. Innovations in semiconductors allowed for the development of smaller, faster, and cheaper processors, leading to the proliferation of laptops and portable devices. At the same time, the rise of software and applications enabled computers to perform a wide range of tasks, from word processing and spreadsheets to video editing and gaming. The foundation had been laid for the digital age, where computers would become indispensable tools for work, education, and entertainment. As the 21st century unfolded, the history of computers entered a new phase of unprecedented innovation and influence. Computers, once confined to laboratories and offices, became ubiquitous in daily life. The rise of the Internet transformed them into powerful tools for communication, commerce, and creativity. High-speed connectivity allowed billions of devices worldwide to interact seamlessly, giving birth to the digital ecosystem we now inhabit. One of the defining advancements of the early 21st century was the emergence of mobile computing. Devices like smartphones and tablets, powered by sophisticated operating systems such as iOS and Android, revolutionized the way people accessed and shared information. These compact devices packed the computing power of earlier generations of supercomputers into a form factor that fit into a pocket, making technology accessible to a broader audience. Apps, a new frontier of software innovation, allowed for endless customization and functionality, ranging from social media and navigation to health monitoring and gaming. Simultaneously, the growth of cloud computing redefined how data and software were managed. Instead of relying on local storage and processing, cloud services allowed individuals and organizations to access vast computing resources over the Internet. Companies like Amazon Web Services, Google Cloud, and Microsoft Azure enabled businesses to scale operations efficiently, while everyday users benefited from tools like Google Drive and Dropbox. This shift not only improved convenience but also facilitated global collaboration and innovation. The rise of artificial intelligence, AI, marked another milestone in computing history. Machine learning algorithms, powered by advancements in processing power and data availability, enabled computers to perform tasks that previously required human intelligence. From natural language processing and virtual assistants like Siri and Alexa to breakthroughs in image recognition and autonomous vehicles, AI demonstrated the potential to reshape industries and daily life. Quantum computing, though still in its infancy, began to emerge as a revolutionary frontier, promising to solve problems far beyond the reach of classical computers. The social implications of computers also became a central theme in the modern era. Social media platforms, enabled by powerful computing and networking technologies, transformed how people communicated and shared information. While these platforms fostered global connectivity, they also introduced challenges such as misinformation, privacy concerns, and the ethical use of technology. The digital divide, highlighting disparities in access to computing resources, became a critical issue for policymakers and technologists alike. Gaming and entertainment also experienced a technological renaissance due to advancements in computer hardware and software. Realistic graphics, powered by GPUs, and immersive experiences through virtual reality, VR, and augmented reality, AR, created new dimensions of interaction and storytelling. Esports and streaming services turned gaming into a cultural phenomenon and a lucrative industry. As the decade progressed, the Internet of Things, IoT, emerged, connecting everyday devices like appliances, vehicles, and wearables to the Internet. This seamless integration of technology into physical objects enabled smarter homes, cities, and industries. However, it also raised questions about security and the ethical use of data, further emphasizing the need for responsible innovation. Looking toward the future, the possibilities for computing appear boundless. Advances in biotechnology, such as brain-computer interfaces, hint at a future where humans and computers could merge in unprecedented ways. Space exploration, driven by powerful computers, aims to unlock the secrets of the universe and expand humanity's presence beyond Earth. Meanwhile, efforts to create sustainable and energy-efficient technologies reflect the growing awareness of computing's environmental impact. The history of computers is not just a tale of machines but a chronicle of human ingenuity and its profound impact on society. From the humble abacus to the AI-driven systems of today, computers have continually redefined what is possible. As they evolve, they hold the promise to address humanity's greatest challenges while opening doors to worlds yet imagined.